This is section 4.6, part 5. We're going to look at two things. We're going to look at plotting a complex number in the coordinate plane, and then we're going to find the absolute value of a complex number. So, let's come down to the first problem that we have, and it's -6 plus 8i. We've got a complex number in standard form. We've got a coordinate plane here, but it's a little different because we're dealing with complex numbers. We're dealing with imaginary numbers, so we don't have axes of x and y. One axis, the y-axis, is your imaginary axis. The x-axis is your real axis because we've got a real number and we've got an imaginary number. So, notice each of the tick marks go by 2, and when you plot this complex number in this coordinate plane, all you are going to do is simply plot a dot. It's going to take up one little spot. There's not a line, it's just one dot. And how you do that is you're starting at 0, 0, and you want to move along the real axis, alright, which is going to give us -6. So I want to go over to -6, so it's just -2, -4, -6. And then I'm going to move up the imaginary axis and by this number. So I'm over -2, -4, -6, and then I'm going to go up 2, 4, 6, 8. Alright, so my point is right there. And this is -6 plus 8i. So -6 moves us -6 on the real axis. 8 moves us up +8 on the imaginary axis. And there's your point. And that's it. That's how we plot complex numbers. Next, we want to take the absolute value of the complex number, and that's what I have over here. We have the absolute value of the complex number a plus bi. And to find the absolute value, you simply square a and you square b, add them together, and lastly take the square root. So, if we wanted to take the absolute value of -6 plus 8i, we're going to square a, which is -6, and we're going to square b, which is 8. And then we'll take the square root. By squaring it, a negative will always turn to a positive, so the the -6 squared is +36. 8 squared is +64. We're going to take the square root of that sum. And we see 36 plus 64 gives us 100. So we want to take the square root of 100, which gives us our answer of 10. So the absolute value of -6 plus 8i gives us the answer of 10. Let's try one more. Come on down. And we've got the complex number 1 plus 3i. The first thing we'd like to do is plot it. And what I'm going to do is I'm going to change the scale. I originally had it going by 2s, but I'm going to make them go by 1s. Alright, so 1 plus 3i. Remember, what we know as the y-axis is now our imaginary axis, and what we know as the x-axis is now our real axis for real numbers. So I'm going to start at 0, 0. I have a real number of 1 and an imaginary number of +3i, so I go up 3, and there's my point. +1 on the imaginary axis, +3, so I have 1 plus 3i right here. And that complex number is now plotted. Next, we're going to take the absolute value of 1 plus 3i. And remember, we take a, which is 1, and we square it. And we add that to b squared. b is 3, and we square that. And then we take the square root of the sum of those two numbers. So 1 squared is 1, 3 squared is 9. Take the square root of that sum. 1 plus 9 is going to give us 10. Square root of 10 can't be simplified, right? If we tried to do our number or our factor tree, we'd get down to 2 and 5, and then we'd have 1 and 5 and 1 and 5, and this would just go forever. So we don't have any nice pairs, so we know that 10 can't be simplified. So our final answer is the square root of 10. So the absolute value of the complex number 1 plus 3i is the square root of 10.